Hello! We've reached the most important concept in game performance optimization. Draw calls. They are the bridge connecting the CPU to the GPU. This concept is very important, so focus carefully in this video. So, what are draw calls? They are commands sent from the CPU to the GPU. Each draw call includes a set of data we talked about before, such as vertex and index buffers. Some shader informations like it's a hair or skin or something like that. I will mention shaders later. And material data, of course, is it transparent or opaque, and the position of the object in the world. Basically, a draw call tells the GPU where to place the object in the scene, how to color it, and other necessary data. These buffers and data are prepared earlier by the CPU, so the draw call is a gateway to send the data to the GPU. Right now, we are in the stage of placing 3D models in the world. The objects are already placed, but when the frame starts running, the first thing happens inside the CPU, preparing the buffers, doing visibility tests to check if the object is actually visible, and after this preparation, the draw call happens. It sends the information. Then, the graphics API translates the information to the GPU. So, we will now focus on draw calls specifically. Why do we care about draw calls? Because each draw call adds overhead to the CPU. The more draw calls, the more pressure on the CPU. This can cause delays before the GPU even starts its work. But I need to mention that everything is different in Nanite. The whole system is changed, so the draw calls that we will talk about are not the same draw calls of Nanite. So the CPU actually started work, of course, we know that there is some physics, there is some animations, some visibility testing, and finally, after all these processes, we got our models transforms. So after that, we need to go to create the draw call. As a CPU, of course, I will create my first draw call in the next few milliseconds. And then the draw call will be converted to 3D model by the GPU. So everything is good right now, but the problem is, even if I have just one model duplicated a lot of times, I need to wait a little bit here, because as a CPU I prepare the data, send the draw call, create the mesh, prepare data, send draw call, create the mesh. We will do this a lot of times, even if we have the same mesh repeated a lot of times, which is a problem. That's why we talk about draw calls, because we need to reduce this process of talking between, or let's say going around between the GPU and the CPU a lot of times, because there is some data transferred here. Even if we have one model, we do a lot of work going around the CPU and the GPU. So we need to reduce that. We need to make it easier for the CPU, because we need to make, let's say, most of the work for the GPU instead of the CPU. In fact, when developing for PS5 or Xbox Series X or even modern CPUs, they are strong enough that you don't need to worry too much about draw calls. Basic principles are still important though. For example, even a CPU like Intel i7, okay, let's say 8th generation, is strong enough to handle draw calls for most games. So now, most of the load is shifting from the CPU to GPU. Less work for the CPU, more freedom to write complex logics using C++ blueprints. Now, let's talk about the types of draw calls. There are many, but let's start with the most important, geometry-based draw calls. Anything related to 3D is a geometry-based. So, when placing an object like a cube with one material, that equals one draw call. So, the number of draw calls per frame is the number of meshes times number of material slots per mesh. For example, if you place the same mesh and material, that's another draw call. So every mesh added equals one more draw call. For example, this is our cube, and it's our first draw call. This cube contains actually one material, so it's just one draw call. Then, if I copy or duplicate this cube, that means it's another draw call, even if they have the same material and the same static mesh. The third one, another draw call. So 3 draw calls from the same mesh. And each time I add another material, it's another draw call. So the same mesh with 3 for example, 3 materials, that means 3 draw calls. So how we can reduce draw calls and reduce CPU load? There are 2 methods. So the first one, which is merging, and the second one is instancing. With using these methods, even if we have a lot of meshes, we will have just 1 draw call, but with the same materials. But first, we need to observe how the world behaves without merging or instancing. Let's look at statistics. By typing stat unit, we can monitor performance stats. Stat unit show a lot of informations, and one of them is the draw calls per frame. In this example, draw calls show as around 187, but this includes actually some editor UI like Windows or any other elements open in the scene. So to get an accurate number, close all unnecessary windows and collapse panels. Make sure only the main scene is visible. Also, there is a huge difference between this editor and standalone game, and also when building the game and profiling. So we'll talk about that also. In this case of no merging or instancing, every object counts as a separate draw call, even if they share the same mesh and materials. Let's say we spawn 10 by 10, so it's 100 material. I created an actor to spawn static meshes that can be around 100 draw calls. The actual numbers might vary slightly due to the engine noise, because, as I said, the engine adds his own draw calls also to these numbers. If each mesh has 3 materials, then 100 meshes times 3 materials equals 300 draw calls, because each one will have 3 draw calls instead of 1. The Unreal has some features to manage draw calls in an intelligent way, but when we don't use techniques like instancing or merging, every object is treated as an independent draw call. Alright, let's quickly talk about the 2 concepts, instancing and merging. I would just let you know what are these concepts because we'll talk about them in static mesh section. Instancing involves 2 main techniques, ISM and HESM. ISM, instance and static mesh. This is a technique that lets you create a lot of objects in one draw call. You will tell the GPU, please create X copy in these positions with a single piece of information, and it's one draw call. That's a concept. You create a group of meshes with one instruction. Of course, it doesn't duplicate the mesh itself. It uses the same mesh, so it doesn't increase the disk space. But there is a condition. All those meshes must have the same static mesh and the same material. Unfortunately, this feature doesn't give you individual LODs or calling for each mesh. However, it's good for Nanite. Why? Because Nanite uses a special system for LOD and calling. It's different from the traditional workflow. Of course, we'll talk about that in static mesh section, but just to summarize, LOD means changing mesh quality based on distance to the object. Calling means hiding the object if it's not visible on screen. These are basics, concepts you should know. As for hierarchical instance and static mesh, they work the same way as regular instancing, but with a little difference. Each object has its own LOD and calling. So, same idea, but with individual LOD and calling. So, now, with instancing, if you change the material of just one of the object, you get a new draw call. So, in instancing, all objects must use the same material. But if you want to change the material, the solution is use a master material. Instead of creating different materials or master materials, you create a material instance and you only change some parameters in each one. This way, you are applying one base material and only changing a few values per instance. This keeps it at one draw call for the material and the meshes. So in this example, you get one draw call, one master material, and one material instance, and you create your variables and you will modify the color, for example. So this is one draw call, one material applied, let's say one material instance, and I will modify the variable of my color. That means I will play with the color, for example, one is green, other is pink. Then it's still one draw call because my system will create one material instance and play with some variables inside the GPU. So for me as a CPU, I have one draw call. So you need to use material instancing. So now let's talk about merging. The difference between merging and instancing is that merging
It's like creating a brand new mesh with its own vertex and index buffers, its own data in the disk. And of course, a little data will be added also in the VRAM, because the engine sees it as a completely new object. So when you merge multiple cubes, for example, inside your map, they are combined into one static mesh asset, because it's useful when you have many repeated objects in the world. So instead of using instancing, you can just use merge. You can merge them into one object and duplicate that merged object around the world, and you will still get the one draw call. Okay, you ask me why I use merge, because instancing is obviously the best solution. When using merge, you will have the ability to customize your duplicated meshes. For example, by lowering the quality of some background elements. While it looks like there are many high detail meshes, they actually use fewer triangles. This flexibility, something instancing doesn't allow. So we will explore these advantages in more detail in the static mesh section, so don't worry. How to use instancing or merging? First, you need to select all actors that you need to merge or instance. So now you have a lot of meshes. Just go to merge actor settings. Then this window will show up. You will choose between merge or batch. Merge is that we're talking about, it's just creating a new static mesh, while batch is creating an instance of duplicated meshes. So I would choose batch, and I will select the type of my instancing. For example, hierarchical instance static mesh or instance static mesh. Choose one of them, and that's it. You can choose replace source actors, because it will remove all actors from the scene. Make sure to collapse your items, close tools, maximize screen in the engine, because all UIs in your engine are counted as draw calls, so we need to minimize them. So as you see, we added just one draw call instead of 100 draw call. Okay, we will talk about these techniques in the next videos, so don't worry, it's just an introduction. Now there is another kind of draw calls, the one related to LODs. So every time you switch LOD, which is level of details, like moving from LOD 0, so like close up to the model, to LOD 1, which is, for example, a little bit further, you get a new draw call. This draw call includes a lot of informations. If you have 3 materials on an object, you get 3 draw calls. Okay, we'll talk about that. But if you change from LOD 0 to LOD 1, and LOD 1 has also multiple materials, this means multiple draw calls. So make sure only LOD 0 has multiple materials, and any other LOD should have just one material. So we'll talk about these techniques in LOD section, so just to avoid creating or wasting your draw calls. And remember, all these processing, LOD switching, vertex buffer creation is handled by the CPU. If you use too many LODs in one scene, the CPU overhead increases. That's one of the problems of draw call. We can say this problem is partially solved by Nanite. There are many types of draw calls for decals, lighting, shadows, UI, particles. Also in blueprints, if your blueprint doesn't contain a static mesh, it doesn't count as a draw call. Even if you place it in the world, if there is no mesh, so there is no GPU cost. Draw calls only happen when something needs rendering using GPU. Blueprints themselves don't use GPU, they run on the CPU side. So don't worry about draw calls if you just use actors without any static mesh. You can read more about draw calls in this article. There is a really interesting YouTube experiment. When Visual Tech Art channel tried to force only one draw call per frame, unfortunately the test didn't work because Nanite draw calls are different from LOD draw calls. Nanite doesn't rely on traditional GPU work. The CPU sends everything directly to the GPU, and everything is rendered as one set. So it doesn't need many draw calls. Unlike LOD systems, where the CPU has to send a draw call every time you change LOD. So that's why Nanite's workflow is different, so one draw call for Nanite will not make your performance better. Also, LOD is relying on each individual object, so you can't create all objects with one draw call. That's it for today. See you in the next video.